Automatic is a software development. We are a software development company, and we are responsible for WordPress. How many of you are familiar with WordPress? WordPress, okay. So that's what I do. But today, I'm going to be talking about security, specifically security on the HPC environment. The title of my presentation is Securing Your HPC and Other Infrastructure. Okay, so on the agenda today, we're going to briefly gloss over the need for HPC security. There we'll talk about why is this suddenly necessary for us to start looking at security as a concept in HPC environments. We'll talk about vulnerable parts of the HPC system. That is, the HPC is a complex combination of so many parts, sorry. That is the nodes, your network, your storage, and things like that. So what parts are we concerned about when we are talking about security? Because the concept of security, depending on what part you're talking about, differs. Then we'll talk about who's responsible for securing the HPC system. Is it the administrator? Is security left to the user? Or is it the provider of the hardware you're using? Or when it comes to the case of the cloud, are the providers of the cloud responsible for securing your environment for you? We'll talk about approaches to HPC security. And then in conclusion, we'll evaluate how we look at security today as a whole. Because, like you see over there, security is a dynamic concept. There's no hard and fast rule to approaching security. There's no particular way that you can secure your systems. You only have to look at the way the industry works today. For instance, back in the day, it used to be that you just slap antivirus on your systems and everything will be okay. But now hackers are smarter. The way they attack systems, the way they work now is very different. So you as administrators, you also have to up your game and ensure that you know what vulnerabilities are out there, and then you prepare yourself in response to ensuring that your system is not compromised. Back in the day, there was less focus on security for HPC installations. Can we get that thing? Let me see. Okay. There was less focus on security for installations because most of the time, HPC systems were self-contained on-premise, and they were usually used by academicians and sometimes in the medical industry, where people do simulations and long-run researches. But nowadays, HPC has changed. A lot of players in the private industry have seen the advantages that are in HPC and the advantages of parallel computation, and a lot of people are coming into that game. So, because of the scale of HPC and because of the way data works in this modern dispensation, it is very necessary for both the cloud and your on-premise solutions to work together. And when that comes into play, that means we're now talking about a network. You have to ensure that the data you have on the cloud can interact with the data you have on-premise. So that introduces a line of vulnerability for your installations. You now have to ensure that the people that have access to the data that is inside your HPC environment are only the authorized identities. The problem which on-premise HPC centers, that is a huge data center where you have all the processors and the CPUs on rack, is that you always don't find utilization for those resources. You have a huge system, you have racks, you have huge power utilizations that can't be used all the time. If you look at the strategy employed by the cloud nowadays, you can spin up a VM in 2 seconds and have a working hypervisor. You can have any system, operating system that you want. And then you can have a cluster within minutes. And you can use it for just the amount of time that you want to use it. When you are done with that, what you do is you spin it down. That way, you're only using the resources that you need. For HPC centers, you can't have that if it's on premise and it has no connection to the outside. That means that anybody who wants to work on those nodes has to be inside the center by themselves. They have to go there physically. That also means that there will be a lot of resources that are going to be underutilized. So this was thought about, and a lot of HPC centers started to open up their resources for people outside of their immediate community. Now you have universities opening up resources for other universities. You have government agencies allowing other agencies to work with their HPC resources, so that at the end of the day, that resource, because for those of you that are familiar with physical HPC centers, it's very capital intensive. You have rows and rows of racks of systems that are being powered daily, every day, and if you don't find utilization for it, it's just going to be a big box that is just occupying space. So there was a revolution, and we now have HPC centers that have login nodes and that you can connect to using SSH and protocols like VPN. What that means is that it used to be before that you had to be in front of the system or in front of a terminal before you can access the nodes in the HPC. But now, with a login node, they give you credentials, and you can log in from anywhere in the world, and you can access the cluster or nodes that you desire. You can transfer your workloads to the HPC center via the login node, and you can run all your simulations. You can run your computation, and you have results, and you can download that as well. So, like I was saying, that introduces an extra layer of security. Now people can connect. Now you have to trust users to keep their, what do you call it now, their credentials safe. You understand? If, just like in the traditional systems, if you have a set of credentials and you give it to people, or you keep it insecurely and somebody has access to it, they can run malicious programs on those systems. Then, additionally, with the vast amounts of data being created daily, there was a need to often scale beyond physical bounds, and hence hybrid HPC installations arose. What you find now in the modern times is that you have to combine what you have on premise with what you have in the clouds. This is not only restricted to HPC installations. You do it also in the private industry as well. You have some infrastructure that is already running on ground, but another software comes around or another technology comes around, and you think it's a good idea to combine. For instance, where I come from, where I'm working right now, we have data centers. All our web servers are in private data centers, but there are technologies that we cannot host by ourselves. We have to depend on external providers to run our email servers. We also have to depend on external providers to run some of our databases. In other words, we find ourselves in a situation where on-premise solutions now have to interact with solutions on the cloud. So when that happens, you now have to start looking at security from a different perspective. Each person that accesses solutions on the cloud must have an identity. Then you have to start thinking of granular permissions. Not everybody needs the same level of access. Perhaps the system administrator should be able to access passwords in an encrypted format. But a normal user shouldn't be able to do that. So when you start combining on-premise solutions with solutions on the internet, for instance, you now have to start looking at security at a different point of view. You have to start educating your users on what to do and what not to do when they are online, on how to best protect their credentials. So this introduces a new concept HPC, as system administrators, we now have to constantly think about, just as much as we are looking for compute, we are looking for a system that is very powerful. We have to start thinking of security from the ideation process. If you are going to set up an HPC center, you have to start thinking of security from the moment you start talking about the devices and the systems you're going to buy. Before you start talking about the firewalls and the network components you're going to use, you have to start thinking about how to secure them. Similarly, on the cloud, before you connect any external device or platform to your on-premise situation, you have to look at how best to secure it. Because just as much as you're trying to do the business of the day, trying to make money, trying to do the next research, there are bad actors out there who are trying to gain access to your data. We're trying to disrupt the things that you're doing, and we are trying to get access to your system, because an HPC center is a lot of compute. There's a lot of processors that are out there. When people get access to it, they can use that to commit havoc in the real world. The realities of connected or hybrid HPC environments. Sorry, 1 second. Okay. To provide access to the international community, most centers now provide login nodes that are often accessible on public networks, like the internet. And then these login nodes are often gated by protocols like SSH or VPN, which is something we are all familiar with, right? Everybody knows how to work with SSH. And VPN, if you want extra security, so that even though you are connected via the internet, your connection is totally encrypted, and nobody can, even if they can sniff it, like maybe introducing a man-in-the-middle attack, whatever they see is encrypted, so they can do nothing with it. Then we're also in the age of what you call the hybrid HPC installations. It's not a new concept, but it's a scenario I've already explained, where people combine compute you can get from on the cloud with the compute that is on premise. So the capabilities of this kind of integration is such that you can easily upgrade all your kernels. If you have a physical system, it's a big deal to always upgrade your operating systems, to upgrade all of your software systems. You have automated systems, but it's still a big deal to upgrade them, because now you have a system or a CPU that is hardware-based. If that goes out of fashion, I don't know, there's nothing you can do, except maybe you organize a deal, a buyback, or an upgrade with the provider. But if your CPU or processor goes out of fashion, or has a vulnerability that is revealed, that is allowing bad actors to take advantage of that system, there's nothing you can do but look for a way to patch it and keep connecting with your provider. But if it was on the cloud, or if it was a hybrid situation, what happens is that you can spin it down and spin it up with perfectly upgraded and perfectly patched kernels and operating systems. So for on-premise systems, it is very, very difficult to upgrade, and those become more exposed, especially if you're already exposing login nodes to the internet via SSH and HTTP. It's also very difficult to scale up or down without any form of capital investment. When you have a physical on-premise solution, if anything is to be added or removed, for people that are familiar with it, it is capital intensive and might require levels and levels of bureaucracy for you to change anything. The cloud provides the flexibility to scale up or down. And then cloud connectivity provides a layer of vulnerability as well. Similar to what we have where just a login node is provided. When you have cloud solutions interacting with your on-premise solution, you now, like I said, have to think about how to secure this. Later on, we'll talk about methods we can use for securing your installations. But it's something an administrator needs to constantly think about. People will try to breach your systems. People will always attempt to hack your systems. Once you are online, people will always try to bring you down. So the only way to keep abreast of this situation is to make sure that you're running the latest upgrades for your operating system and your kernels are constantly patched. For on-premise installations, there is a new vulnerability that has been discovered. Cisco, which is a provider of networking components that everybody uses, found out that they dispatched a set of routers to a client. Before those routers got to the client, somebody has switched the processor and introduced code that is going to be loaded at runtime that essentially just gives access to a hacker. So when you're thinking about security, you also have to think about the supply chain. It has to be from, like I said, from the ideation process. It's not just, oh, the system is in front of me, I can start working about it. You have to think beyond just securing your SSH systems. You have to think about the capacity building of the people that will use it. You also have to think about constantly monitoring traffic. Because hacking is a very expensive game. It's very lucrative. And last journal I was reading, they said that in 2017 combined, the data that was stolen in January, just January alone, 2021, is more than all the data that was stolen in 2017. Which tells you that a lot of people are making money from hacking. And the truth about it is that hacking is just information that is stolen and sold to another person. When somebody gets access to your data, for instance, in a research facility, the kind of vulnerability that you can have is someone gets access to your data and introduces it into the market before you. Or they introduce malicious code that ensures that that code doesn't behave the way it should behave. And I've seen cases where people introduce commands into your process while they're ingesting data. That data itself is being corrupted and deleted. So your data results are no longer trusted. So there's what you call the chain of command inside they do it in law. You have to ensure that from the supply chain to the point of installation, the integrity of your components are always ideal. Thank you. I just quickly want to introduce, because if you're talking about security, sometimes we need to learn about what has happened in the past, and now we can maybe avoid some of this. This is a bubble map of some of the companies, organizations that have been hacked. And this map gets more clustered as you get closer to 2021. Facebook was recently hacked, and it wasn't the first time. Yahoo has been hacked close to 3 times, I think. So it's an ongoing game. If the best of the best in terms of organizations and corporations that are big and have all the money in the world, with all the security facilities that they have, can still get hacked, the way you need to think is not, I can't get hacked. How can I react if eventually it happens? Because maybe the reason you are not compromised yet is not because you are very good at your job. It's just because maybe the data that you produce is not profitable yet. I can imagine how many people are sitting in front of their desks right now thinking, if I can just hack Facebook and get access to that information. You know the kind of information people put in Facebook. A lot of people will want that, from robbers to kidnappers to all sorts. Because what don't you put on Facebook? You put your numbers, your email addresses, your connections, who your father is, your mother, your birthday, and everything. So if somebody were to get access to that, now that is just at the personal level. But imagine a case or a scenario where you have research for the cure for cancer, and people have had data there, they're trying to generate, they've reached a particular stage. Imagine COVID, for instance. It took them years or months at least to provide a vaccination. that is workable, that is testable. And if you have some experience with science, you know these things usually takes years. And they have data somewhere. They can't just create that vaccine from memory. It has to be stored somewhere. And somebody were to get access to that, and then they release it on the black market. Or worse, they infiltrate, they doctor it, and then they release it so that people think they have the real thing, but it's been altered such that it's now harmful to people. So in that scenario, that data is no longer useful. Not only is it not useful, it's costing that company that has invested millions and billions into arriving at that data after running simulations and tests and doing a lot of, what do you call it in the medical industry? Trials. And they have that data stored somewhere. Now it's corrupted. Not only is it going to cost them the wrong results, it's only going to cost them revenue. Because now people may die. You know. So look at that map. It's an even distribution. There are hotels there. There are government installations. There are social networks. Nobody is spared. I imagine that a lot of universities or research institutions are not represented here because they are not required to, submit their information whenever there's a breach. I don't know too much about that. But these companies are expected to. I want to share a showcase with you. Equifax. I don't know. Has anybody heard about Equifax? Nobody? You've heard about Equifax. So you know what happened? Equifax. Equifax, yeah. Equifax is a company, it's a credit bureau. The Americans, they usually store financial health information with a company like Equifax. But along with that information, you have personally identifiable information like social security number, date of birth, blah, 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 blah. So they were hacked, their data center was hacked. And how did this happen? In 2017, they had an application that was still running an old patch. A vulnerability that was clearly reported. But because somebody did not do their job well, or maybe they said, I'll do it tomorrow. Now, there was a vulnerability in that application. It was a customer-facing application. They didn't patch it. And a hacker that was very aware of that kind of a vulnerability and who knew about their system and knew that they were using that software, hacked it, and used that to gain access into their data center. And from that, he was able to get access to their database. He was able to exfiltrate or download information about people. About 143 million people's details were exposed online. Now, even if they had access to their data, if it was encrypted properly, now, their certificates had expired. That was something they should have noticed as well. They didn't notice. Now, these are things that could be avoided. Why am I saying this? I'm trying to make you understand that beyond just the machines that we use, there are other components to security, like the people, that we work with, like responding on time to security features. For instance, if somebody was on the lookout when this vulnerability was announced, they should have patched those systems in question. All right, so it cost them a lot of money. Their reputation as a credit bureau is now in question. You understand? But what happened at that point in time, they had to tell people to now start changing all their information. Because as it happens, a lot of people use the same details they use on one side, on other sides. So that is an example of what can happen when all the components that come together have issues. So I want us to start doing this a little bit interactively. Okay. Thinking about security is something that is uh, hands-on. It's not. There's no expert in security because sometimes the hacker can know something before you do. It's just a question of what you know. So basically, you need to keep your ears to the ground. What are the main components of an HPC system? There are three of them. I just wonder if we know, if you have an idea. Sorry? Yeah, it's very vague. It's very vague. But those are the primary components. What are the components of an HPC solution? Just try. I will try my best to guide you. Yeah. Sorry?
Three
No,
components.
no. That is too detailed. The very high-level components. Or let me put it this way. What about a node? We all understand the node as being just one part of the cluster, right?
Yeah.
So what are the parts of a node? Maybe that's where the question is vague.
A part of the node.
Of a node, yes.
Cluster.
Sorry? The parts of a node, yes. Components of a node.
Software.
Software.
The
CPU, thank you.
yes,
Compute.
yeah.
Yeah, parts of compute. Yeah, compute. Yeah. So we have, let me go through one by one. We have compute. Yeah, we have, sorry? Network, thank you. Network. Sorry? And storage. Thank you so much. I'm sorry about the question being vague. Yeah. But I wanted to bring to your fore some of the things you need to be thinking about. When you look at the HP system as a whole, you start seeing the complexity. But when you take it a node in part, then you see how best to maybe secure your data. Yeah. Now, I'm sure everybody knows what these are. Now, in attempting to protect your system, you still have to be aware of what you call the CIA. We all know that as well. The confidentiality, integrity, and availability. So there's no need to gloss over that, right? Everybody knows that. Okay. All right. So what are the resources we need to protect from compromise? Data. Thank you. Sorry? Data. Yeah. Data. Processed data from research is often the target for bad actors. We need to ensure that data is always secure both in flight and at rest. In practice, data is not always in storage alone. Sometimes data could always be in the RAM, in flight, which is in the pipes, in transit, yes. So, and it can be stolen from any of those parts. The easiest solution would be to encrypt what you have in your drives. But for HPC, sorry? Go ahead, please.
I want to know what about data on processing? Because here you just take two. On a flight at rest.
Data in process.
Yes, in process.
Yes. Data in process is also in flight. That is, if you look at it as either being at rest or being in the RAM, being worked on, processed, analyzed. That's what you were talking about, right? Yes. Yeah. But I also talked about data in the pipes. That is being transferred from, maybe if you have a connection to a public cloud, you transfer data before it gets to your storage solution or before it gets to the program that works on it. So data can either be in the pipe, in the RAM, which is where it's going to be if it's being processed, yes, or at rest. Do you understand? Okay. So a very good kernel hacker can get access to data in any of these situations. The most expensive part of an HPC is when your data is hacked. The damage done could be anything from financial damage to reputational damage. At the least, it sets you back to go and start from the beginning. And sometimes it takes a long time, even with HPC systems, to get your final results. And then there is also the question of duplicacy. If you have a result and somebody else has it, so that addresses confidentiality. You understand? So, but while you're trying to protect this, you also have to ensure that you apply measures that don't adversely affect your computational power. In traditional systems, you will just slap on maybe antivirus, anti-malware, a firewall, all on the same system. And what they don't tell users is that all these things also need your RAM. They need space on your hard drive. Your computer is not going to be operating at 100% capacity because now you've introduced systems that are going to be running forever, you know. So that degrades the RAM with time. Now, if you put that on every node, the equivalent, what do you call it now? The processing power is going to be limited, but not only going to be limited for one node, for all the nodes. So the combined effect of that is that the entire HPC system is now 50% or less, depending on how fast your antivirus is. So people don't typically use antiviruses for HPC systems. I'll discuss some of the solutions they usually use for compute. Now, if your HPC system is insecure, bad actors can also gain administrative access. That is root access. So hackers technically like to steal other people's resources to steal. So they steal to steal. They don't have their own installations. That's the truth. Now, HPC is very powerful. So if you leave the front door open for a hacker, even if your data is not attractive, now you've given him instrument to use to hack people. And he's not only going to, imagine brute force, trying to log into somebody's interface. So what he can do that may take 30 days, now is going to take maybe a few hours. Now you are just letting someone maliciously use your HPC system. So you need to think about that. So who's responsible for securing the HPC system? All right, sir. Question, please go ahead.
Okay, I have a question.
Okay.
You talk about CIA,
Yes.
confidentiality, integrity, availability. But in security, they said we can have the three.
Yes.
We can have the three.
At all times, you can't have the three. Yes, they are mutually exclusive.
Okay. In the cases of HPC, which we can have two, in security, we can have two.
Okay.
I want to know which kind we can have in HPC. Is it confidentiality and integrity, or confidentiality and availability, or another?
I have to answer your question.
I want to know which we must privilege.
No, it depends on what your
HPC.
priorities are. Exactly.
Please.
It depends on what your priorities are.
Okay.
If you are nearing the stage of getting a result, your data is much more important to you. You understand? But if you are ingesting data at the beginning of your experiment, for instance, if anything happens, you just start all over again. So integrity matters at that time when you're starting. Confidentiality only matters when your data results is at hand. You understand what I mean?
Yes.
Yes, that's information. So while those three things cannot exist at the same time, you can work with them in parts.
But my problem exists because when we are implementing HPC, is for everybody, is for
Yes.
everybody. But depending, maybe some scientific, he just need integrity. Another person will need availability because
Yes.
we can propose a cloud.
Okay, I
So,
see.
In the side of the owner of HPC, what will be the owner's priority implementing his HPC? Integrity or confidentiality or availability?
I think
because
that-
we have
that
any
question-
kind of person.
That question is a preference question. If you have HPC installation, what the owner of the HPC will install might not be what fits your narrative. You understand? But you
Yes.
just have to understand what they are prioritizing.
Exactly.
Do you get?
Now,
And if it's the scenario where they allow you to specify, so that they can adjust their network. Okay, what are you looking for? Are you much more interested in your data? Then they will adjust all the controls of the system to ensure that only your data is safe. You understand? Yeah.
But wait, yes, I understand that. But do you have a recommendation for the owner of HPC? Because you say when I want to use HPC, according to my preference, I will choose to use this one or another one.
Yes.
But here I'm asking question about the HPC owner.
Okay.
There are recommendations to say, okay, when you want to have your HPC, it is preferable to have say CI or to have.
Okay.
You see what I mean?
Yeah, I understand what you mean, but I think okay, go ahead. Okay.
I understand what you mean, but for me, I'm not an expert, but I think that integrity is the
Optimum, the most important.
No, is the common.
Okay.
Is the common level for every cluster. I think because if you have not a truly that data, you will the experimental is faulty, and this is not. But in case of perhaps you are in a chemical industry, like the
pharmacology, cosmetics,
like this, your data is so many important for you because you have to spend a lot of time and spend a lot of money for for one project, and if the data from this project is stolen, you will lose a lot of data. Perhaps the industry of the pilot,
okay.
and so on and so forth.
One more contribution, yeah.
Thank you, sir, for making it interactive.
All right.
For me, I will go with what he says. It's an issue of preference here. From what he described, it's like you're packaging a service by, he said, the owner of the HPC. But I see that you are packaging a service. Just like he said, it will be a matter of preference. That you are packaging a solution for a customer, then he said if you have the privilege to say which one, maybe what you package for this
might be different.
From this at different times. But like he said, the preferences will have to be balanced per the solution you are packaging. For this one, it may be this. For that one, it may be that. I see it as a solution packaging. Yeah.
And combining them. And then I think those schools of thought, like you said, it depends on whether you're talking about, ultimately, you're referring to the system administrator. If you say the owner, it's still the administrator who's going to be in charge. But then if it's a commercial venture, you understand, because there are those. Or if it's just a loaner, like this is my HPC, I'm letting you work on it. You understand? So for a commercial venture, it might be such that you think about the people that are going to use your infrastructure and think, I'm going to make it such a way that we can choose what is exactly. You understand? So it's another level. It's not a security question. It's more or less like I can't say morality, because if it's a business venture, now you're bound by certain principles. But if it's a loaner, you could just say, oh, go and use. And based on your level of expertise, you can adjust the system as you want it. Are we clear on that? Oh, yeah.
Contribution about that. I'm not sure that the end user have to choose what is the best service for security. I guess that it's the owner and the HPC administrator. Because if you focus on integrity and the confidentiality is not there, you maybe have data corrupted. If the availability is not there, you will not have data. So you have the HPC owner can merge all systems, and then the end user will only focus on the disponibility of the data. That's it. So you don't have you as an end user to say that the HPC administrator, I just need integrity. No. That's my part, I guess.
No, but you have to understand that the end user you are referring to sometimes is also an administrator. You understand? Sorry, before you ask one more question. Now, just a minute. The information is not always confidential. It's not always confidential. If you're dealing with information that is already available to everybody, and this time around you're just crunching numbers to arrive at the result. So that's why sometimes you could select and say, oh, I don't want confidentiality. I want more compute so that I can arrive at integrity and availability. You understand? So that's why some of those things are flexible for you to choose what you want to. Exactly. Trade-off. Exactly. That's the right word. Okay. Oh, last question. Yeah.
Please, when you are presenting the vulnerabilities,
Okay.
you talk about the free component of HPC, compute, network, and storage.
Okay.
But you know that most of the vulnerability come from operating system and application running in the environment.
Yes.
I want to know why you don't talk about the vulnerability of operating system and application we use on the environment.
I talked about it. I talked about the kernel and the operating system. I talked about your being aware of the fact that this can be compromised right from the supply chain. I talked about being able to upgrade. If you can remember, being able to upgrade and patch your systems to the most recent version. You understand? So that has already been talked about. Okay. Who's responsible for securing the HPC system? Questions? Okay. Oh, don't sound.
Okay. I've seen you have talked about storage, security, and compute security. What about network security?
Yeah, we'll talk about it.
Ah,
We'll talk about how to attack network security. It's part of the things we're going to talk about here. And you know you do have a network provider, right? Sometimes it's not something you can't do anything about the networks most of the time. Because your provider is your provider. What you can do is gate the access and ensure that the people that are authorized to enter, enter. And the people that are authorized to leave, leave, if you know what I mean. Like ingress and outgress. Ingress and egress. Only those ports or channels that are open are used, then you can be sure that there's less concern in your network. You still have to monitor the traffic to ensure that what is being done is what is authorized. We'll talk about that later. But the network is one of the rare components that you can't do anything about except gate it. Except you gate it. For instance, if Glo provides you internet access to connect to the internet, you can't do anything except to receive the connection. Then based on how you want to, configure your network, that's your local network, maybe put a firewall in front of it. Then we'll talk about other things we can do. So who's responsible for securing that system? Yes, an interesting topic. Who's responsible for securing the HPC system? Should we talk about the entities that are involved? Sometimes okay, I think you need to click on this. Most organizations will have a full security outfit. That is security professionals that are constantly monitoring the hardware, the software, the network, and everything. But it's not always most, yeah. But more realistically, what you have is a system administrator who's also trying to secure the network that's in charge of. And the entities, the people, the people in question, the hardware provider for on-premise situations, the cloud provider, people like Google, Amazon, the system administrator, which is you, and then the users of your compute. So who is much more in charge of ensuring that everything is secure? In what percentage? More than 50%. Okay. Any other contribution? This has been talked about a lot because now we have a lot of providers who provide infrastructure for you both in the clouds and both on premise. In premise, the situation is simple. Once you have this desktop, for instance, that's it. Whatever they installed on it, whatever preventive measures they put in ahead of time, that's what's there. You are now responsible for the security. You are responsible for upgrading that system, for applying patches, for ensuring that it's up to date. But you're also responsible for other things as well, for like installing malware, anti-malware, antivirus, and things. You're also responsible for ensuring that nobody puts an infected USB into your system. So you have a lot of work to do. That's the case with hardware providers. Once they install your racks, that's where their liability ends. That's where their responsibility ends. Now, for cloud installations, those providers provide you tools because you can't sit in front of, you can't be in the data center yourself. So they have to provide tools that ensure that only the people who have access, who should have access, who have the authorized identities, only those people have access to the system. For instance, they will provide things like gateways with configurable firewalls. They'll provide VPNs if you want to ensure that two devices or two systems talk to each other only and ensure that the communication between them is encrypted. And because there's a plethora of things you can do on the cloud, there's just a little thing that the cloud providers can do. You can decide to install a web server, for instance, which has to have public access. If you have a web server on the internet, everybody should be able to access it, except you say, oh, it's only for a set of people, or except you say you must log in to access resources. So the cloud provider can't fully gate, they can't fully provide all the security that you want. They can only provide tools. And then you as a user of those services, the responsibility to learn about all those tools and how to use them and use them properly. That's why we have certifications for things like Google Cloud, Amazon, Kubernetes, and things like that. Once a provider provides tools, it's your duty as an administrator to ensure that you know the latest, the best, in order to use that system. So in that scenario, the responsibility is shared. Okay. Okay, let me just the system administrator has to be on top of security by monitoring logs, preventing intrusions, and ensuring that data isn't compromised. And as I will reveal later, this is an ongoing job. It's not something you can rest on. You don't have a system that is 100% secure. You only have a system that is secure as at the last time you checked it. You understand? Like I said, hackers keep learning new tricks. If you get the best technology to secure your HPC, and you keep monitoring the logs, and you rest on your oars, something happens tomorrow, and they learn about something before you, and they get access to your system, and they compromise it, it'll be because you weren't paying attention. So you have to be constantly on your toes. You have to be constantly on your toes as an administrator. You have to keep learning what the hackers know. There are forums out there. There are White Hat hackers, security professionals that give out tips on what is happening. You can't know about all the processors that are out there, but you can keep yourself updated by going to sites that provide that information. And because, for instance, let's say your HPC system, all of the nodes, there are virtual aspects, but there are physical aspects as well. Say all of the nodes use a particular Intel processor. Get online and start learning about the provisions of that processor and see if there are any vulnerabilities announced. Manufacturers will always announce vulnerabilities as soon as they hear them. So that's your job as a system administrator, to keep on top of security, that all the components that you work with, even as far as your network provider, you can keep asking them if their connections are up to scale. If their connections are up to scale. And then you keep running simulations on top of your system, especially the access ways, the places where people can connect, to ensure that there are no breachable opportunities for anybody. So, can we take a little break here? I hear that you want to go and take a... We'll continue when you return.
Let's go for the short tea break, 15 minutes, and then we get back. Let our 15 minutes be 15 minutes, please, because...